related to them. So brother 1 had a 1 and a 3. Brother 2 had a 2 and a 3. Oh, there's the 2. Mama had a 3 and a 4, or grandma had 3 and 4. And dad's dead. So kind of hard to test dad at this point. Did we? Okay, so using what you know about genetics, deduce the likely haplotype combination of Karen's father and add it to the pedigree. So look at that. Look at what we know.
1, 2,
2 and 4. 1 and 2.
You would add
1 and 2.
1 and 2.
That has 1 and 2.
1 and 2.
Dad has 1 and 2.
Yep, yeah.
Anybody have any different opinions on that? Why would you say 1 and 2?
Because the children are supposed to have half from each year. So the dad has to have a 1 for each brother and sister. So, because we have a 1 for the brother and 1 for the sister, but the 2 has to be found from the other half, which would be.
Right, what did they all get from mom?
They got the 3.
They got the 3.
So dad.
Other than that, there's a 1 and a 2. So those had to come from dad. So you're right, dad had 1 and 2. So now we have the whole pedigree with everybody's genes on there. And because the sons are related to Karen's family, then they must be related to Karen. So what does this data indicate about Karen's relationships? Well, said that already. Karen's brothers, 2 and 3, has the type 2 haplotype that's present in Karen's sons, but not present in her or her husband's blood. So it indicates that they're related. So on to part 4. Because Karen's blood cells provided no match, the doctors decided to test some of her other tissues as well, including her hair and her thyroid gland. They wanted to know what in the world was going on there. So here's what they found. Now, what HLA haplotypes does Karen have in her blood?
1 and 3.
She has 1 and 3, right? What about in her hair follicles?
4. 1, 3.
1, 2, 3.
1, 2, 3.
Hair, right? So blood, she's got 1 and 3. Hair, she's got 1, 3, 2, and 4. What about thyroid?
Same.
Exact same thing. Look at that. She's got all of those there. So that was kind of the clincher. They indicate that Karen is what's called a whole body chimera, otherwise known as a tetragametic chimera. And what that means is that she resulted from the fertilization, well, she resulted from 4 gametes. Tetra is 4. So you had, basically what happened during conception was that there were 2 eggs, mom had produced 2 eggs, and 2 of the sperm, 2 different sperm from dad, fertilized those 2 eggs. Now what does that usually result in?
Twins.
What kind of twins?
Fraternal.
Fraternal, right? So not identical, because 2 different eggs, different mix of the genes, different mix of the sperm, boom. So what happened?
They fused.
Yeah, usually they stay separate, but something happened early on where they kind of went zoop and made 1 embryo, which means that she had 2 different people, basically, different sets of genes for 2 different people that fused into 1. So part of her body is formed, part of her organs are formed out of the gene set from her twin, and part of them are her genes. Yes?
Does that affect the haplotype so that, like, when they did the test, only 1 set of her haplotype came as a result? Like, wouldn't she have another set from her dad, which would have that too? Like the 2 and 4 I'm missing?
Okay, so, right, so in the blood, it was just, that came from, who did that come from? She had what, a 1 and a 3?
Yep.
Yeah, so it had to be 1 from dad and then from mom.
1 from dad and
There
right.
was another set, a 2 from the dad that was missing.
right.
And
So in this tissue, that was from the 1 embryo, okay? In these ones, somehow we got mixes of all of those crammed in there, okay? So here's what happened. Karen, as we said, is this whole body chimera. And basically, we get what I just explained, 4 gametes, 2 fertilize, the egg and the sperm fertilize, Usually that leads to these twins, but in her case, they formed here kind of this calico mix. And so you end up with an individual that has different haplotypes within themselves. So what